Bismillahirrahmanirrahim. Chapter number 4, Turning Effect of Forces. Yeah, only force. First of all, remember it, force is basically a vector quantity. Anything that is to be vector or scalar means it has some properties. For vector, we consider magnitude along with its direction. Now, we will discuss the effects of force. There are two effects of forces. One is linear, and the second is circular. Linear effect is produced by push or pull, but circular is produced by turning. This turning is further has two types. One is parallel, clockwise, and the second is anti-clockwise. I'll revise it. Force is basically a vector quantity. When we discuss about vectors, then normally we expresses its magnitude as well as its direction. Further is effects of force. Effects of force has two steps. First is linear and the second is circular. Linear effect is produced by push or pull, means you push in this direction and pull in this direction, and similarly this can be like in this way, and it is push and it is pull. But for circular, we normally produce force like in this way, it is clockwise, but if we pull it up, then it is anti-clockwise. And now we will discuss force. Generally the two relations of force is like parallel forces, and further is, or second, unlike parallel forces. Like mean the forces which have same direction. And when you consider unlike forces, means word unlike mean opposite. The forces which have opposite direction. I'll explain it with some examples for like forces and for unlike forces. Suppose you hold a bag of stone, like, take some examples. Consider these are stones. There are some stones. Each stone is applying a force in the form of weight downward. It is its direction. This is a vector quantity. You can mark some other stones that are representing their directions downward. And unlike forces, suppose you have a clock. It is hanging with a wall. In this way, the weight of the clock is downward. It is its direction. And similarly, the support with which it is hanging is applying a normal force in upward direction. Similarly, a ceiling fan this ceiling fan is collectively applying force in the form of weight in downward direction. And the support of the ceiling fan is applying a normal force in the upward direction. We represent normally the normal force with R. And similarly, you can mark on the above example. You can take many examples for like forces. Uh, First of all, remember, when you take the example of the like forces, consider everybody is made up of some particles. Like, we take a brick, it is made up of many particles. They all apply direction in downward direction. But collectively, when we consider the weight of the brick, like W, then we will express it with the sum of all kind of forces, like we mark it W1, W2, W3, and so on. So this is basically a resultant. In other words, the combined effect. And similarly, in case of unlike forces, in this way, any object, like I am taking another example. This is a suspended mass, but we name it weight. Why? Because when we consider mass due to gravity, mass due to gravity, or in terms of gravity, we call it weight. So just check, this is applying, this mass is applying force in downward direction, and similarly this string in the form of tension, it is applying force in upward direction. That is a reaction, and this mass along with its gravity becomes weight, so it is in downward direction. So we can check unlike forces means the forces which have opposite in direction. Reactional force is in upward direction and weight is in downward direction. Both are in opposite direction. This is a short and brief intro about force, and then like force, like forces, like parallel forces, and unlike parallel forces. Stay tuned for next lectures.